Let's use our newfound understanding of the organization of the periodic table and electron configurations to write down the electron configuration of an atom. We're going to use the periodic table as our helper. So let's say we want to write down the electron configuration of mercury. So let's find mercury on the periodic table. Here it is. So what we're going to do is we're going to backtrack. So we're going to work our way back down the periodic table. So we're going to go this way until we find the previous noble gas. So here's the previous noble gas. The noble gas before mercury is xenon. So we're going to start off the electron configuration and say, hey, it has the same electron configuration as xenon. So I put that in brackets. And then we need to figure out what comes next. So I'm going to number these rows of the periodic table. 1, 2, 3, 4, 5, 6, 7. So remember, those rows tell us about the shell number. So with mercury, I start filling the n equals 6 shell. So I'm going to start with 6s. And so cesium would be 6s1 right here. Barium next would be 6s2. So I completely filled my 6s2 subshell. And then I start down here with the lanthanide series with lanthanum. So then I hop down here. And what I'm going to do is work my way across filling the f orbitals. And actually the first column here is a 3d orbital. So we start to fill that, and then we work our way across. We fill all of the f's. So this one would be d1 because it's in the d block. And then I move to 58, which is over here in the f block. So cerium would be an f1. And so 1, f1, f2, f3, f4, f5, f6, f7, f8, f9, f10, f11, f12, f13, and f14. So we've worked our way all the way across this little group right here from cerium to lutetium, and so that's going to be now we need to figure out what row with the F's we start on. So for the D block, it's always n minus 1, and for the F block, it's always n minus 2. That's where we start. So we're in row 6, so 6 minus 2 is 4, so we're going to have 4F, and we've gone completely across it, 4F14. Now we're ready to troop across this D block right here until we get to mercury. So D is n minus 1, so we've got 5D. And we start here at lanthanum, that would be D1. And we work our way across the F block, which we've already done. Then hafnium would be D2, so lanthanum would be D1. Hafnium would be D2, then D3, 4, 5, 6, 7, 8, 9, 10, ignoring the exceptions. So this would be 5D10 by the time we get to mercury. And so that's a way that we can use the periodic table to figure out the electron configuration of any atom that's on the periodic table. Now remember, there will be a couple of exceptions, and I don't care that you get those right, so I want you to just follow the pattern with the exception of these two. I want you to know the exception for chromium and the exception for copper. So those two I want you to know the exceptions for, and we won't memorize the other exceptions that are on the periodic table.